Warning, this video is not targeted to kids and may be inappropriate to younger audiences. Your discretion is advised. Alrighty then. Hello, dudes and dudettes. It's your favorite Reacher Gamer Mix17 here, and yes, I am planning to do 2 videos in one day. Of course, we're continuing off where we left off last time. I'll be finishing off. I will be continuing on by finishing under survival package, warning corrupted blueprint data, which I also forgot to mention that everything under survival package, all 6 of these data entries are actually thrown in at the very beginning of the game, like the second you get your PDA started. So anywho, warning, blueprint database corrupted. Damage to your PDA hard drive has corrupted approximately 80% of stored survival blueprints. Blueprints may be required by scanning a salvaged technology using the handheld scanner or by downloading plans from a onboard data box. In the circumstances, these assets will most likely be found amongst the wreckage of the Aurora. And that is basically it. Finally, we get to move on to the bit more interesting, which is indigenous life forms. So we'll start off with coral, which luckily doesn't have a whole lot. Brain coral, a permanent growing colony of microscopic organisms. This coral species has adapted to filter carbon dioxide from the environment, using the carbon to build the colony and expelling the oxygen that from specialized exhaust funnels. It is quite hardy, suggesting samples from a mature specimen could be grown artificially. Assessment: air tanks are equipped to siphon oxygen from the water where possible. By the way, everything under indigenous life forms is by scanning any of these things. So for instance, scanning a brain coral or scanning any of these things. That's where you're going to most likely find it. And where exactly can you find these things? Everywhere in the world of Subnautica. In the world of Planet 456b, specifically Crash Zone. The crater zone, that you can find any of these indigenous life form scans. Moving along, coral shell plate. This variant of coral has adapted to survive in close proximity to other corals, filtering nutrients from the water and sharing them via a spore-like substance which grows around the base. Assessment: no particular applications discovered. Earthian coral tubes. Genetic resemblance to the giant coral tubes encountered elsewhere suggests evolutionary divergence approximately 100,000 years ago, with this subspecies being substantially lower than in calcium content and specializing in growing in smaller, denser packs at deeper levels. Assessment: no particular applications discovered. Giant coral tubes. The variety of coral formations on 4546b appear to be different solutions to the same problem of mixing water and nutrient flow throughout the colony. These particular variants funnel water through a tube, filtering nutrients as they pass. Their size suggests they have been likely successful. Assessment: coral tube samples are rich with calcium, exploitable in bleach fabrication. Well, there you go. Pyrocoral, I think that's how you pronounce it. This coral species is unlike any other encountered in 4546b. In so far it relies on magma flow rather than water currents to deliver nutrients. As lava rises from the planet's core and erupts at vents, this coral forms around the base until eventually it is surrounded the entire vent. Lava is then funneled through the coral, allowing it to siphon minerals and heat as it goes. I didn't know that. Table coral. Each disc is an individual colony of microorganisms, filtering nutrients from the water. Growth patterns indicate the colonies are in direct competition for positions with superior currents or light. Unlike other coral species, its structure is malleable, softly pulsating as it pumps nutrients to its extremites, I think, and only turning rigid when it senses physical assault. The jewel-like nodes in the surface are concentrated buildups of rare minerals the coral is unable to process. Assessment exploited in computer chip fabrication. Tree mushrooms. Analysis of these large organic structures reveals a microsm, I guess, in cohabiting, and competing life forms. The main trunk of the species of coral, same colonies up to by 50,000 years old. The caps which line it share more in common with earth fungi. Other organisms grow on the structures wherever there is space and light. Surrounding waters is dense with herbivorous life forms in the 1 millimeter to 10 millimeter range. To the extent that larger herbivores appear to have most likely abandoned the area. Assessment exploitable. Next up, subcategory fauna, subcategory carnivores, and there is quite a lot. Amp eel, a powerful and inquisitive predator found inhabiting the deeper waters of the reefs and bulb bush colonies. Number 1, electrical prawns. Torso-mounted prongs generate a powerful electrical current which the amp eel uses to incapacitate its prey. 2. Jaws. A large, flexible jaw studded with sharp teeth. If a faster, stronger, and more hungrier predator lives on the reefs, it appears to avoid the amp eel. Assessment: avoid or incapacitate. Biter. Vicious, pack hunting predator, 94% muscle, 4% connective tissue, and 2% brain. Wow. Indiscriminate when hungry, almost always hungry. 1. Specializes olfactory antenna. Okay. Employed in direction of bodily fluids in the water at impressive range. 2. Secondary pair of eyes, likely dedicated to detecting the peripheral movements of larger predators and hungry members of its own species. 3. Overdeveloped tail fin, I guess, favors outpacing and outnumbering their prey over individual maneuverability. There we go. Calculations suggest creatures up to 100 times the biter's body weight could succumb to a focused assault by a pack of 10. Basically, mutated piranhas. Assessment: avoid packs. Try not to bleed. Blighter. Basically somewhat similar to the biter. A small predator that shares close resemblance to the more common biter, but tends towards a more solitary, less aggressive hunting style. 1. Olfactory stalk. While the red-tipped protrusion on the blighter's head once served as sensory apparatus, it is adapted not to chase but to coax its prey into its path. As prey creatures are attracted to dancing of the stalk, the blighter can dart forward to catch and consume them. 2. Teeth. One row of sharp piercing teeth is all the blighter needs to tear through its prey. 3. Eyes. The creature is found little use for its eyes in the deep, dark caverns it inhabits, and its eyeballs are likely sensitive to nothing more than broad fluctuations of local light sources, i.e. or IG, whatever the heck you want to call it, e.g., when a meal is crossing its path. Assessment: avoid or incapacitate. Bone shark. A large predator, a large and powerful predator that lives in small groups and fiercely defends its hunting grounds. 1. Thickly armored exoskeleton. Suggests defensive adaptation either to larger predators or in-species aggression. Marked similarly to the segmented exoskeleton of the sand shark, suggesting a relatively recent common ancestor. 2. Large eyeballs. Consistent with high light sensitivity, likely for hunting of luminescent prey in low light environments. Generally slow and unresponsive as a means of energy conservation. They will act with uncompromising why am I yawning? Uncompromising speed and aggression against any threats to their territory. Assessment: avoid may be distracted by light sources. Crab snake. This life form appears to live in symbiosis with the local flora. All encountered species have been located within 500 meters of jelly shroom flora, frequently within the plants themselves. Number 1. Jaws. The crab snake has 2 pairs of fangs, one larger claw on either side. It plunges these claws into its prey, locking them in while the inner jaw tears through the flesh. Number 2. Jelly shroom symbiosis. Jelly shrooms provide a perfect lair from which to ambush their prey, to protect their young. The presence of crab snakes likely deters herbivores from feeding on the jelly shroom itself, thus ensuring the relationship continues. 3. Behavior. Crab snakes display territorial behavior when threatened, patrolling the cave system in which they reside. Assessment: avoid. Okay. Crab squid. This large predator can be found in deep waters where it lurks amongst the blood kelp and membrane trees in search of prey. It can deploy a powerful electromagnetic pulse to defend itself. Limbs. 10 limbs feature different appendages for swimming, walking, hunting, and possibly even tool use. Okay. Creatures caught in its grasp are expertly butchered and quickly consumed. Number 2. Behavior. Rays and other illuminated herbivores are its usual prey, and it will approach and attack any light source in its vicinity. Its EMP blast is likely developed as a response to predatoration by creatures with electrical hunting mechanisms. Number 3. Intelligence. While crab squids appear to have larger brains and the resemblance of an intelligent brain of intelligent squids I gotta stop yawning. Of Earth. The organ inside the creature's head is in fact its stomach, which is filled with startling regularity. Assessment. Neutralizes electrical equipment. Lights attract its unwanted attention. Crash fish. Oh boy, this thing. This unusual species has developed an emergency defense mechanism based on mutually assured destruction. Number 1. Forward-mounted eye. Enables the creatures to identify and track potential predators. Number 2. Sulfur plant. The sulfur plant has evolved to feed on sulfuric compounds secreted by the crash fish, which makes its nest within its leaves. Stronger, more protective plants provide superior nesting grounds in which in turn provide the plant with more nutrients from larger crash fish. Number 3. Defense mechanism. Concentrations, I don't know why I had a hard time reading that, concentrations of sulfur build up in the organism over time. If the crash fish collides with something at sufficient speed, the spikes on its torso are impacted, triggering an explosion chemical reaction. Assessment. Equip stasis rifle, repulsion cannon, or similar before approaching shallow caves. Lava lizard. Medium-sized predator adapt for life in volcanic regions, and remarkably able to spit molten rock at its foes. Number 1. Four-mounted mandibles, designed to do maximum damage to prey. Sharp internal teeth tear through flesh and bone alike. 2. Scarred tissue. Likely due to exposure to magma, lava lizards build up a thick layer of scar tissue over time, which enables them to withstand even greater temperatures inside and out. Number 3. Behavior. It is able to both defend itself from burying its body into magma, and to go on the offensive by spitting molten rock at its foes. Assessment. Avoid, especially in the presence of lava flow. How many do we have? We got a tiny bit. Mesmer. Small carnivorous life forms with a unique hunting mechanism that enables it to hypnotize its foes. Outer wings. The mesmer swims using a number of wings which can be angled up and forwards on approaching its prey. Tiny lenses on the surface can be tilted independently to create mesmerizing patterns which flood the victim's brain with enticing messages, interpreted in whatever form it is most convincing by the target. Outer shell. The mesmer can open the jaw-like recess in its protective outer layer shell in order to error. 463. Share its beauty. Do not resist. Assessment. Draw closer. Oh boy. River prowler. A fast, agile moving predator discovered in great depths. Number 1. Jaws. Powerful jaws used for both salvaging prey and warding off larger predators. 2. Torso. Its eel-like torso is highly vulnerable, consisting predominantly a spinal column and cartilage. It shows significant overlap with other eel-like predators on 4546B. Number 3. Attack profile, It will aggressively keep its jaws facing its opponent, but smaller, faster life forms may have an advantage. Assessment. Avoid. I don't doubt it. Sand shark. A powerful, medium-sized predator that burrows into the sand and ambushes its prey from below. As with many predators, it may be possible to temporarily distract sand sharks by feeding any hungry species that draw close. Number 1. Forward dorsal fin. The unusual location of its fins suggests a purpose unrelated to movement through the water. It may be employed by shifting sand beneath the surface or in mating rituals, or it may simply be an evolutionary dead end. Number 2. Segmented exoskeleton. Thick layer armor plating renders the sand shark almost immune to attacks from above. While it is capable of impressive acceleration, its exoskeleton prevents it from changing direction quickly. The sand shark is thus a perfectly designed ambush hunter, but ill-suited to sustain pursuits. Number 3. Feet. Ill-designed for ambulation, likely used to disturb the surface of the sand for the lifeform to burrow into the ground. Assessment. Avoid, be vigilant for ambush in sandy biomes. Now then, give me a second while I do this. Alright, back to reading. Stalker. A streamlined predator encountered in the kelp forest in wait of prey, leaving the safety of the shallows to feed. The stalker likely carved out of its evolutionary niche at the sweet spot between seed and size millions of years ago, and may be one of the oldest species on the planet. Of course, my phone has to distract me and stuff. The stalker appears to be attracted to titanium deposits, which tends to sharpen and put stress on its teeth. As with many predators, it may be possible to temporarily distract hungry stalkers by feeding them. Number 1. Teeth. The stalker's teeth is unusually hard and fast-growing. Its elongated snout can deliver huge biting pressure to larger attackers, while also being used to reach small herbivores seeking refuge amongst the rocks. Number 2. Night vision. Wait, what? Retinal layering on the eyeball suggests adaptation for nighttime hunting. Okay. Number 3. Dorsal ridges. These ridges can be moved independently to deliver superior maneuverability. Number 4. Pelvic fins. Long and powerful, the stalker has evolved to hunt the fastest of prey. Assessment. Stalker teeth may have applications in enameled glass fabrication. Stalker teeth. Extended analysis of acquired dental samples has been completed. Samples match the species designated stalker. Stalker teeth inhibit extraordinary lightness and strength, and contain only trace amounts of calcium. The edges show signs of wear and are studded with metal flakes, providing the evidence that stalkers chew on metal deposits in order to sharpen their teeth. Assessments. Applications of natural substance with enameled glass fabrication. Warper. An aggressive creature with the ability to teleport itself and others in space. Okay. No genetic crossover identified with indigenous life forms. Demonstrates no recognized defense behavior. Head. Mechanisms located in the head region provide its warping capability, which is used to stalk its targets. Torso. It appears to hunt other life forms, but no digestive organs have been identified. Internal structure considerably more complex than other known organisms, unable to distinguish whether organic or artificial in nature. Assessment. Further research required, which we found out stuff. Deceased. There is just a tiny bit, so yay. Ancient fossilized skeleton. The skeleton of a million-year-old armored carnivore Projections suggest this life form may have been larger than any living creature encountered on the planet. The oceans at the time would have been very different to support life forms of this size, with more open geography and many more individuals in the Leviathan range. Gargantuan fossil. The fossilized remains of an extinct super predator. Its sheer size would have prohibited from entering such an enclosed space, suggesting the geography of the planet has shifted around them over time. A true apex predator. Dated approximately 3 million years ago. A ribcage. Measurements suggest the creature is an eel-like structure. Calculations suggest that it is only the front third of the specimen, which is crazy long. The remains now supports a vibrant microcosm of life. Note, there are series of precise angular indentations of the ribcage, suggesting a third party has taken samples of the specimen in previous time. Mixed Leviathan fossils. These fossils likely came from the ancient ancestors of leviathans, which inhabits the planet today. The relative size and delicacy of the bones suggest they formed parts of the ear canal or other complex internal structure. Reaper Leviathan skeleton. Reapers are ill-suited to high-temperature environments, suggesting this creature was forced down into the active lava zone by coordinations outside of its control. Trace muscle tissue remains on the bones, indicating the specimen died in recent months. Burns and other physical damage to the skeletal structure likely became prey to something bigger. Remains of research specimen. The skeletal remains of a vast predator housed in an artificial habitat. Number 1, habitat. The environment constructed to house the specimen suggests it was kept alive in containment for research purposes for months or even years. Organic matter indicates the habitat was once supported extensive plant life, though it has since decayed. When the facility collapsed, this specimen was either left to die or killed on the spot. Evolution. While it shares some skeletal traits with the biter and sand shark, including a distinctive double eye sockets, this fossilized specimen is significantly larger. It features unusual forearms rarely seen in aquatic specimens. This species is likely gone extinct in the past 1,000 years, and its evolutionary relatives have evolved almost beyond recognition. Ribcage samples. A display case containing an array of ribcage cages harvested from the indigenous life forms. There is a particular focus in the instance of vertebrate skeletal structures. While some of these skeletons match organisms encountered on the planet so far, most cannot be matched with confidence, suggesting either they are specimens out there not yet accounted for, or that they have become extinct since these samples were collected. Sea dragon skeleton. The semi-intact skeletal structure of a Leviathan-class predator. Number 1. Head trauma. There is clear evidence of a massive physical trauma to the head. The damage is so severe it likely caused the cause of death, and must have occurred somewhere nearby. Damage is consistent with high-speed collision with solid object. Number 2. Age. Something with the environment has helped it preserve these remains, but calcium decay suggests it suggests an approximate time of death of 1,000 years ago. Bone growth suggests the creature was in egg-laying stage of its life cycle. Large herbivores. Oh boy. Crimson Ray, one of the largest rays on the planet, displaying genetically docile behavior. Well, number 1. Thick scaling. Scales formed on the skin protect this ray from extreme temperatures, allowing it to survive in areas unpopulated by competing scavengers. Number 2. Forward-mounted eye sockets suggest a predatory evolutionary history left behind long ago. Assessment: inedible. Cuttlefish. A small gray-colored herbivore, the cuttlefish displays the high levels of intelligence, curiosity, and attachment. Strangely, this species has not been encountered in the wild, and the scanned specimen has been artificially hatched within an alien containment unit. Number 1. Life cycle. Oh crap. In an absence of wild specimens, little can be known for certain about the cuttlefish life cycle. It is possible the environmental conditions have changed, forcing the species the edge of extinction, and leaving its eggs in a permanent stasis. It is almost possible the cuttlefish has been genetically altered or even imported to planet 4546b from another world. Number 2. Behavior. We do know that the cuttlefish is a herbivore which displays highly social behavior in its interspecies interactions, as was observed on the planet Earth dolphins before their extinction. This creature seems to understand the concept of other minds, the prime indicator of true sentience, and attempts to communicate with a series of chirps and chirroops. I don't know. And number 3, interaction. Evidence suggests a cuttlefish is capable of understanding and following simple commands, in addition to assessing the emotional state of individuals around it and responding in kind. Assessment. Emotional connection between living organisms is an essential component to the psychological health. Gasopod. Oh man. A slow-moving life form and one of the larger herbivores of the planet, providing a substantial meal to would-be predators. The gasopod protects its domain by filling the surrounding water with poisonous and corrosive pods. Those contents dissolve even synthetic fibers. Number 1. Filtration system. Yeah. Thick, non-reactive skin and multiple gill layers render this creature impervious to noxious acid clouds it produces. Number 2. Algae gland. A bulbous sac-like appendage at the rear end. A luminescent yellow algae glows inside the sac and produces the poisonous compound. Abdominal muscles can contract, causing the algae gland to emit the noxious compound into the surrounding water. Number 3. Large pelvic fins. Capable of powerful movement through the water when moving in small herds. Number 4. Behavior. Gasteropods appear to be social in nature and may even use their emissions in their relationship rituals. Their audible calls can be likely signifiers of nearby threats or food sources. Assessment. Approach with caution. Acidic pods may be retrieved and repurposed. Ghost ray. This species has adapted to deep sea conditions. Its body is fully protected by a translucent skin, and its large wings are capable of generating considerable thrusts. Number 1. Poisonous flesh. It is, as is common for rays on 4546b, the ghost ray's flesh is inedible, making it one of the more resilient herbivores. Number 2. Feeding behavior. It feeds on plant matter that has settled on the ground in deep sea caverns. Assessment: inedible. Jelly ray. This species has adapted to low light environments with a translucent, luminescent body. Number one, luminescent body. This adaptation may help to lighten up the surrounding area for foraging, warding away predators, and identifying the organisms of other of its kind. Number two, light sensitivity. Larger creatures have been seen swimming in the jelly ray's wake to take advantage of the light source for their own ends. In the ray the ray itself will approach light sources, perhaps mistaking them as others of its own species. Assessment: inedible. Rabbit ray. A herbivorous aquatic life form. Rabbit rays appear to live serene and solitary lives with few predators and natural sense of curiosity and awesomely poisonous flesh. Wait, what? Okay. Number one, ears. Twin orange appendages mounted on the head sense vibration in the waters. Number two, undulging wings. Markedly similar method of transportation to the Earth rays. Zero genetic resemblance detected, suggesting these two species independently developed similar solutions to their environmental circumstances. Evidence indicates a large side-facing eyes are relatively recent adaptations, and it is likely there are related ray species in other environmental biomes on the planet. Assessment: inedible but harmless. Sky ray. God dang it, we have too many rays. The sky ray is a bird-like head. Has a bird-like head and feathered wings, which is enabled it to fly. Sky rays are commonly found circling floating structures and rarely venture far out to sea. They will perch on dry land, but are prone to flee on approach. Wings. Number one, wings. Although the wings give some resemblance to silhouettes on waterborne rays of 4546b, analysis shows no greater genetic overlap of those species with the planetary advantage. In fact, the sky ray appears to have split off the evolutionary tree much earlier than most. Number two, diet. Largely seed-based, the sky rays have not been observed diving for food, which implies they rely on land-based plants for their survival. Assessment: presence may indicate nearby dry land. Okay. And that is the large herbivores. Small herbivores. Number one, starting off with bladderfish. This unusual herbivore appears to be mostly defenseless, and bears little resemblance to other life forms around it. Number one, semi-permeable bladder. The bladderfish is able to filter air and seawater into its body cavity through a unique membrane which surrounds its spine like a bladder. This allows it to remove and consume organic particle caught in the way and adjust its buoyancy. Number two, open-end vesicle tubing. It can be angled and contracted to pump out water and archive low-velocity guided propulsion. Largely oblivious to threats and particularly immobile at night, its only identified defense mechanism is that it's composed entirely of water, air, and cartilage. Assessment: edible. Oxygen may be retrieved from the bladderfish and added to tanks on consumption. Oh, I didn't know that. Membrane has applications of natural filtered water filter. The boomerang. A herbivore encountered in large numbers, found to frequently shallow waters and move in schools. Number one, serrated teeth. Suggests adaptation for other other herbivores are unable to digest. Number 2, twin fins. Unusually, these species' two fins are cartilaginous extension of its skeleton, and they are less prone to damage and provide superior propulsion, but are also harder to grow back. The bright blue tips are in fact the ends of its digestive tract, where the luminescence of the coral is consumed and most focused. Most active during daylight hours and prone to flee on approach. The boomerang can easily be observed at night when the luminescence gives it away and seeks shelter of the seabed. Assessment: edible. An extreme evolutionary adaptation where 90% of the life form's body mass is dedicated to the ocular cavity. Number 1. Oversized eyeball. Deep-set rings of the lens suggest specialization for identifying its predators in low-light environments, long before they come to attack range. Number 2. Underdeveloped fins. Incapable of fast movement, this species is vulnerable to agile predators at close range. Shark species may have evolved hunting techniques to close on the eye unseen from above, below, or behind. This organism and the common peeper share a common evolutionary ancestor. While the eye has sacrificed maneuverability, it shares and enhances its cousin's powerful eyesight. The ancestral alpha peeper may have been one of the first life forms on planet 4546b and developed eyesight many millions of years ago. Assessment: edible, low calorie count. Garyfish. Slow-moving and curious herbivore, camouflage indicates adaptation for herbivorous behavior on the ocean floor. Number 1. Eye stalks. May be beneficial when watching for predators from behind places amongst the coral. Number 2. Behavior. More active during daylight hours, but slow and docile at all times. The garyfish survival depends on the combination of camouflage and predators who can get a more filling meal elsewhere. Assessment: edible. Oh boy, we got quite a lot. Holefish. A very small herbivore found in low numbers, often around cave systems entrances and where their skin coloration blends into the background. Number 1. Bored out tailfin. By manipulating the size and the shape of the hole in its tail, it can perform unpredictable maneuvers. Number 2. Size. Smaller than most other herbivores, presumably due to the lack of vegetation and low light environments. Assessment: edible. Hoop fish. Small school mentality prey fish with a unique method of propulsion and a distant relative of the bladderfish. Number 1. Antenna. Rather than swimming, this lifeform uses its green antenna, which encircled its body, to alter the composition of the water in front of it, allowing it to sail into low-density space created. Number 2. Purple-green coloration. It may be a camouflage adaptation for mid-range light wavelengths, possibly indicating the hoopfish is more active at dawn and dusk. Number 3. Behavior. While schools of hoopfish will perform periodically and evade predators and massé, their behavior is more social than its defensive and lone hoop fish are often found hunting for food and displaying generally curious behavior. Assessment edible. Next up we got the hoverfish. However, I'm gonna take a small break to do something real quick. Alright, well, with that done and out of the way, right, continuing on with the hoverfish. A small, cautious herbivore commonly found in kelp-rich environments. That's it. Oh, and I can't even go downward. Alright, number 1, charged foot pads. 6 unique limb appendages feature charged pads capable of ionizing the surrounding water. The hoverfish uses this ability to maintain its position against the current and as it feeds from the kelp and lichen. I don't know, something like that. Assessment edible. Magma ray, whatever. This organism is an adaptation of the common boomerang, evolved to survive in high temperature environments. 1. Coloration. Dark red coloration helps the subspecies to blend into indigenous rock environments. Orange, detailing resembles active lava flow, denoting more cautious behaviors. Number 2. Behavior. Marginally bolded than its yellow-dwelling cousin, the magmarang will nonetheless flee any creature larger than itself with impressive speed. Assessment edible. Oculus. This species shares genetic similarities with the common peeper. While the shallows and the cave systems are separated just by a few meters of rock, foodstuffs and threats in each biome are completely different. It is possible a small school of peepers was once cut off the caves, and the oculus species is how they adapt. Number 1. Highly developed night vision. Large complex eyeballs provide the herbivore superior vision in the dark and in intense phobia of light. Number 2. Lack of beak. While the peeper uses its beak to break through corals, the oculus likely feeds on soft fungi growths on the jelly shroom caves and thus no longer needs one. Number 3. Separated tail fin. The caves in which the oculus live in make it hard to escape from fast predators. The oculus has adapted to by splitting its tail fin into 5 tendrils. These tendrils prevent it from swimming as fast as its shallow water cousin, but each can detach and regrow, enabling it to swim more easily when caught. Assessment edible. Peeper. A fast prey fish encountered in shallow waters and enriched in protein. Number 1. Developed side-facing eyes, capable of discerning colors, not just in shallow waters, but in a variety of lighting conditions. It is also capable to close its eyes, thus preventing light from reflecting off the lenses and rendering the peeper almost invisible to nighttime predators. Number 2. Powerful fins. The species has evolved powerful fins which enable rapid acceleration in still water, and the ability to leap meters into the air to avoid pursuers. Number 3. Beak. Likely used to break down corals and through vegetation, an unusually large nasal cavity serves no obvious purpose and appears to be specifically evolved to detect a singular specific enzyme. Nothing encountered on the planet so far produces a matching odor. Expulsion tubes. The tubes attached to the peeper's torso are connected directly into its stomach and gills and appear to be designed to expel its contents on demand. Purpose unclear. While the peeper is well adapted to survive in shallow waters, the number of its features serve no discernible purpose. It would appear to be just as well suited to survive in deeper waters and is somewhat more intelligent than the usual smaller herbivore. Assessment: edible, high calorie count. Further research required. Red eye. The small herbivorous creature with poor maneuverability evolved to inhabit high temperature environments. Number 1, thermal camouflage. Deep red and orange coloration enables the subspecies to blend into volcanic environments and reflect environmental thermal energy, thus rendering it almost invisible to most predators. Number 2, thermal vision. Dedicate light-based eyesight. It's impractical at these temperatures, and the red eye has developed thermal vision in its place. In this species' volcanic domain, enabled edible plant matter and potential predator are the coldest entities in range. Assessment: edible, low calorie count. I am having a hard time reading now. And something. A small herbivore and a distant relative of the common peeper, sharing that species' well-developed, side-facing, approximate size and body profile. Number 1, coloration. Dull green coloration from deep water camouflage. Luminescent tail coloration, likely part of mating behavior. Number 2, diet. Filters algae and other plant material from the water via foregill-like forward-facing something. Orpheres. Assessment: edible, high calorie count. Spadefish. A medium-sized herbivore found in deeper waters. Number 1, single eye. Observed swimming near to the seabed, from where it can keep its one eye on predators in the water above. Number 2, mottled green coloration. Commonly encountered in plant-rich environments, the spadefish is well adapted to hide amongst the vegetation. Number 3, behavior. Spadefish tend to move in loose sorrels, and despite their low speed, it will take necessary measures to avoid and confirm predators. Assessment: edible. Spinefish. Small school mentality prey fish closely related to the hoopfish. Number 1, gray coloration. A combination of near translucent flesh with white rib-like markings makes this fish a deathly appearance. It takes advantage of this to avoid attention of its predators. Number 2, behavior. Moves in schools for protection, but will something and flee if necessary. Whereon these fortunate enough to escape the gaze of their assailants will make for the seafloor and hide amongst something detritus. Assessment: edible, low calorie count. No kidding, I ate in one of those things and it wasn't the greatest. Leviathans, something that we are. Whew, man, Leviathans are something else, aren't they? Okay. so I don't know why I like paused for a second there. I just had to like think for a second. Alright, so I'm basically running out of time, and I'm gonna stop right here. So all I gotta say is thank you everyone for joining me in this grand adventure of Subnautica Let's Explore. And yeah, I'll see you all in the next episode. Goodbye.